When electrical contractors need to run conduit or cabling underground, trenching becomes necessary. There are several methods available, each with its own advantages and disadvantages. Firstly, there is manual trenching. This method involves using hand tools like shovels, picks, and mattocks. It's suitable for shallow trenches in soft soil, but is labor-intensive and can be time-consuming. Secondly, we have hydro-trenching. This technique employs a high-pressure water jet to cut through the soil. It creates clean, narrow trenches with minimal damage to the surrounding area. Hydro-trenching can be used in various soil types, including hard clay and areas with many roots. Thirdly, vacuum excavation is another option. This method uses a vacuum truck to remove soil from the trench, leaving a narrow, undisturbed trench with minimal disruption. It's ideal for sensitive areas or locations near underground utilities. Fourthly, plow trenching uses a plow-like device to cut a trench by displacing the soil horizontally. It's suitable for long, straight trenches in soft soil and can be faster and more cost-effective than other methods. Fifthly, trenchless methods offer alternatives that minimize surface disruption. Directional boring involves using a drilling rig to create a hole underground without excavating the soil. Horizontal directional drilling, or HDD, is similar to directional boring, but it uses fluid to lubricate the drilling process. Pneumatic excavation utilizes compressed air to break up soil and remove it through a vacuum. Sixthly, chain trenching uses a machine with a rotating chain to cut through the soil. This method can create wide trenches quickly, but it may damage adjacent structures. The selection of the appropriate trenching method depends on several factors. These include the soil type, trench depth and width, accessibility to the trenching area, proximity to existing utilities, time and cost constraints, and environmental concerns. For example, if the soil is very rocky, manual trenching would be very difficult. Or, if there are many existing underground utilities, vacuum excavation may be better than using trenching methods to reduce the risks of damaging other utilities. Regarding soil type, understanding the composition of the ground is crucial. Sandy soil is easier to dig through than clay, while rocky soil may require specialized equipment. The required trench depth and width will also influence the choice of method. Wider and deeper trenches might necessitate the use of machinery for stability and efficiency. Limited access to the trenching area can restrict the size and type of equipment that can be used. For instance, if the trench is located in a narrow alleyway, a large excavator might not be feasible. The presence of existing underground utilities, such as gas lines, water pipes, and fiber optic cables, adds another layer of complexity. Methods that minimize soil disturbance, like vacuum excavation, are preferred to avoid damage. Time and cost constraints are always important considerations. Some methods are faster but more expensive, while others are slower but more economical. The environmental impact of each method should also be taken into account. Some methods generate more noise, dust, and waste than others. Trenching operations also require strict adherence to safety protocols. Inspecting the trench for hazards, such as buried cables and pipes, is essential before starting any work. Providing adequate trench supports, like trench boxes or shoring, is crucial to prevent cave-ins. Workers must use personal protective equipment, including hard hats, safety glasses, and gloves. Maintaining safe working conditions, such as proper lighting and ventilation, is also vital. Before commencing any trenching project, it is paramount to thoroughly investigate the site. This includes identifying and marking the locations of all underground utilities. Contacting the local utility companies or using a one-call service, such as 811 in the United States, can help prevent accidental damage to underground infrastructure. A site assessment should also consider the soil composition, water table level, and any potential environmental hazards. Soil testing can provide valuable information about the soil's stability, moisture content, and presence of contaminants. The water table level can affect the stability of the trench and may require dewatering techniques. Additionally, the presence of any environmental hazards, such as asbestos or lead, should be identified and addressed appropriately. Based on the site assessment, a detailed trenching plan should be developed. This plan should outline the specific trenching method to be used, the sequence of operations, and the safety measures to be implemented. The plan should also include contingency plans for unexpected situations, such as encountering unforeseen underground utilities or unstable soil conditions. The plan should be reviewed and approved by a qualified engineer or safety professional. Selecting the right trenching method is not a one-size-fits-all decision. It requires careful consideration of the project's specific requirements, site conditions, and safety considerations. By following a systematic approach, electrical contractors can ensure that trenching operations are performed safely, efficiently, and with minimal disruption to the surrounding environment. Manual trenching is the most basic and traditional method. It involves using hand tools, such as shovels, picks, and mattocks to excavate the soil. Manual trenching is best suited for small projects or areas with limited access. It is also a good option when working near sensitive utilities or in areas where the use of machinery is not feasible. However, manual trenching is labor-intensive and time-consuming, making it less practical for larger projects. Hydrotrenching, also known as water jetting, uses a high-pressure stream of water to cut through the soil. The water jet dislodges the soil, which is then removed by a vacuum system. Hydrotrenching is a precise and efficient method that can be used in various soil types, including clay, sand, and gravel. It is also effective for excavating around delicate utilities or in areas with limited space. Hydrotrenching minimizes soil disturbance and reduces the risk of damage to underground infrastructure. However, it requires specialized equipment and skilled operators. Vacuum excavation, also known as air excavation, uses a high-velocity airstream to loosen the soil, which is then removed by a vacuum system. Vacuum excavation is a non-destructive method that minimizes soil disturbance and reduces the risk of damage to underground utilities. It is particularly well suited for locating and exposing buried utilities without causing damage. Vacuum excavation is also effective for removing debris from trenches and for cleaning up spills. However, it can be slower and more expensive than other trenching methods. Plow trenching involves using a plow-like device to create a trench by displacing the soil horizontally. The plow is typically mounted on a tractor or other heavy equipment. Plow trenching is a fast and efficient method for creating long, straight trenches in relatively soft soil. It is commonly used for installing underground cables, pipes, and conduits. However, plow trenching can cause significant soil disturbance and is not suitable for areas with sensitive utilities or unstable soil conditions. Trenchless methods offer alternatives to traditional excavation techniques, minimizing surface disruption and environmental impact. These methods include directional boring, horizontal directional drilling, and microtunneling. Directional boring involves using a drilling rig to create a pilot hole along a predetermined path. The pilot hole is then enlarged using a reaming tool. Directional boring is suitable for installing underground cables, pipes, and conduits under roads, rivers, and other obstacles. Horizontal directional drilling is similar to directional boring but uses a drilling fluid to lubricate the drilling process and stabilize the borehole. Microtunneling involves using a remotely controlled tunneling machine to excavate a tunnel underground. The tunnel is supported by steel or concrete segments. Microtunneling is used for installing large-diameter pipelines and tunnels under roads, railways, and other critical infrastructure. Chain trenching uses a machine with a rotating chain equipped with cutting teeth to excavate the soil. The chain cuts through the soil, and the excavated material is removed by a conveyor system. Chain trenching is a fast and efficient method for creating trenches in various soil types, including hard and rocky soil. It is commonly used for installing underground utilities such as water pipes, sewer lines, and gas lines. However, chain trenching can generate significant noise and dust and may not be suitable for sensitive areas. In addition to the trenching method, the type of backfill material used to refill the trench is also important. The backfill material should be carefully selected to ensure that it is compatible with the surrounding soil and that it provides adequate support for the underground utilities. Common backfill materials include sand, gravel, and crushed stone. The backfill material should be compacted in layers to prevent settling and to provide a stable base for the surface. Safety is paramount during trenching operations. Excavations deeper than 1.5 meters or 5 feet require shoring or sloping to prevent cave-ins. Shoring involves installing support structures, such as trench boxes or hydraulic shores, to stabilize the trench walls. Sloping involves cutting the trench walls at an angle to reduce the risk of collapse. Workers must be trained in safe trenching practices and must wear appropriate personal protective equipment, including hard hats, safety glasses, and steel-toed boots. A competent person must inspect the trench daily to ensure that it is safe to enter. Additionally, all underground utilities must be located and marked before any excavation work begins. Ignoring these safety precautions can lead to serious injuries or even fatalities. There are also several environmental considerations to keep in mind during trenching operations. Soil erosion can be a significant problem, especially in areas with steep slopes or unstable soil. Erosion control measures, such as silt fences and erosion blankets, should be used to minimize soil loss. Stormwater runoff can also carry pollutants into nearby waterways. Sediment traps and other stormwater management practices should be implemented to prevent pollution. In addition, the disposal of excavated soil must be done in accordance with local regulations. Contaminated soil may require special handling and disposal procedures. Trenching operations can also impact vegetation and wildlife. Trees and shrubs should be protected from damage, and wildlife should be avoided. In sensitive areas, such as wetlands or riparian zones, special precautions may be necessary to minimize environmental impacts. By carefully planning and executing trenching operations, electrical contractors can minimize the risks and maximize the benefits. Soil composition plays a significant role in selecting the right trenching method. Sandy soils are generally easy to excavate, while clay soils can be more challenging due to their stickiness and tendency to compact. Rocky soils may require specialized equipment, such as rock saws or hydraulic breakers. The presence of groundwater can also affect the stability of the trench and may require geoterring techniques. The depth and width of the trench are also important considerations. Deeper and wider trenches require more extensive shoring or sloping to prevent cave-ins. The type of underground utilities being installed will also influence the trench dimensions. For example, large diameter pipes require wider trenches than small diameter cables. Accessibility to the trenching area can also limit the choice of methods. Confined spaces may require the use of smaller equipment or manual excavation. The proximity to existing structures, such as buildings and foundations, must also be taken into account. Vibration and soil disturbance from trenching operations can damage nearby structures. In such cases, trenchless methods or manual excavation may be preferred. The time and cost constraints of the project are also important factors. Some trenching methods are faster but more expensive than others. The contractor must weigh the trade-offs between speed and cost to determine the most appropriate method. The environmental impact of the trenching operation should also be considered. Some methods generate more noise, dust, and emissions than others. The contractor should strive to minimize the environmental footprint of the project by using environmentally friendly equipment and practices. The permitting process for trenching operations can vary depending on the location and the type of work being performed. In many cases, permits are required from local municipalities or utility companies. The permitting process may involve submitting detailed plans, obtaining approvals, and paying fees. It is important to understand the permitting requirements before starting any trenching work to avoid delays and penalties. A detailed site investigation is essential before starting any trenching operation. The site investigation should include a review of existing utility maps, a visual inspection of the site, and soil testing. The purpose of the site investigation is to identify potential hazards and to gather information that will be used to select the appropriate trenching method. The site investigation should also include a survey of existing vegetation and wildlife. Sensitive areas, such as wetlands or endangered species habitats, should be avoided whenever possible. A comprehensive trenching plan should be developed based on the site investigation. The trenching plan should outline the specific trenching method to be used, the sequence of operations, the safety measures to be implemented, and the environmental protection measures to be taken. The trenching plan should be reviewed and approved by a qualified engineer or safety professional. Regular inspections of the trenching operation are essential to ensure that the work is being performed safely and in accordance with the trenching plan. Inspections should be conducted by a competent person who is trained in safe trenching practices. The inspections should include a review of the shoring or sloping, the atmospheric conditions, and the equipment being used. Any unsafe conditions should be corrected immediately. Proper backfilling and compaction of the trench are essential to ensure the long-term stability of the underground utilities. The backfill material should be carefully selected to match the surrounding soil. The backfill material should be compacted in layers to prevent settling and to provide adequate support for the utilities. The compaction should be performed using appropriate equipment, such as vibratory plates or rollers. Restoration of the trench area is the final step in the trenching operation. The trench area should be restored to its original condition as closely as possible. This may involve replacing topsoil, reseeding grass, or paving the surface. The restoration should be performed in a timely manner to minimize disruption to the surrounding area. Ongoing maintenance of the trench area may be required to prevent settling, erosion, or other problems. Regular inspections should be conducted to identify and address any potential issues. The maintenance may involve adding backfill material, repairing erosion damage, or replacing damaged pavement. Continuous improvement is essential to ensure that trenching operations are performed safely, efficiently, and in an environmentally responsible manner. Contractors should regularly review their trenching practices and identify areas for improvement. They should also stay up to date on the latest trenching technologies and techniques. By continuously improving their trenching operations, contractors can reduce the risks, minimize the costs, and protect the environment. The Occupational Safety and Health Administration, OSHA, provides regulations and guidance on safe trenching practices. These regulations cover a wide range of topics, including shoring and sloping requirements, atmospheric testing, and worker training. Contractors should be familiar with the OSHA regulations and should ensure that the trenching operations comply with these regulations. State and local regulations may also apply to trenching operations. These regulations may cover topics such as permitting requirements, environmental protection measures, and utility notification procedures. Contractors should be familiar with the state and local regulations that apply to their projects. Industry standards and best practices can also provide valuable guidance on safe and efficient trenching operations. These standards and best practices are developed by organizations such as the American Society of Civil Engineers and the National Utility Contractors Association. Contractors should consider incorporating these standards and best practices into their trenching operations. Worker training is essential to ensure that trenching operations are performed safely. Workers should be trained in the hazards of trenching, the safe work practices, and the emergency procedures. Training should be provided by a qualified instructor and should be documented. A competent person is a person who is capable of identifying existing unpredictable hazards in the surroundings or working conditions which are unsanitary, hazardous, or dangerous to employees, and who has authorization to take prompt corrective measures to eliminate them. A competent person must be present at the trenching site to inspect the trench and to ensure that it is safe to enter. A competent person must also be responsible for implementing the safety measures and for enforcing the safe work practices. Emergency procedures should be in place in case of an accident or other emergency at the trenching site. The emergency procedures should include instructions on how to contact emergency services, how to evacuate the trench, and how to provide first aid. The emergency procedures should be communicated to all workers at the trenching site. Regular safety meetings should be held to discuss the hazards of trenching and to reinforce the safe work practices. The safety meetings should be held at least weekly and should be documented. Documentation of the trenching operation is essential to ensure that the work is being performed safely and in accordance with the regulations and standards. The documentation should include the trenching plan, the site investigation report, the inspection reports, the training records, and the emergency procedures. The documentation should be kept on file for a specified period of time.